All right, so we're going to take a look at some quadratic word problems. We're going to go through each example. Again, I want you to pause where needed in order to graph, in order to plot points, whatever it may be, answer some questions here. So the height of in feet of a golf ball hit into the air is given by h equals negative 16t squared plus 64t, where t is the number of seconds elapsed since the ball hit the ground. You graph h on your calculator for 0 to 4. Okay, so I'm using my graphing calculator. I'm going to y equals. I'm plugging in negative 16. Now, we don't have t, we have x. So x squared plus 64t, 64x. It says use table. Remember, second graph gives us the table, because if I just press graph on here, especially on the calculator without changing the thing around, the computerized ones are a little bit easier because you can kind of move the graph around. I won't have it in my screen. So second graph, and I want 0 to 4. So what I'm going to do for this, I am going to create a little table here. So xy, which is really t and h, 0, 0, 148, 264, 348, and 40. Okay, so I'm going to plot this. Now, if you look at my graph here, it's quadrant 1. We may have talked about it in our other classes, but quadrant 1, this is all positive values. It's positive h values and positive t values. We can't go negative seconds, we can't go negative feet for this example here. Let's see, how many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We have to go to 64. There's 20 boxes. I guess we'll go by 4s because that'll make the most sense here in order to get it up here. So 0, 4, 8, 12, 16, 20, 24, 28, 32, 36, 40. 44, 48, 52, 56, 60, and 64 would be there. We may have to change our scale depending on what we're doing here. So I'm plotting these points 0, 0, 148, boom, boom, 264, 348. Remember symmetry here once I hit a certain point depending on the graph here, and 40. I'm going to connect my dots here, and this makes sense. The ball goes up and it comes down. Now, no arrows, because once the ball hits the ground, okay, the ball hits the ground there, it doesn't keep going. What is the maximum height? Height in this case would be feet, so the maximum height is 64 feet. That's the vertex, part of the vertex. How long does it take? Okay, how long does it take? We would see at what time. That would be 2 seconds. And I could see this from the graph or the table. How long did it take the ball to hit the ground? Well, at 0 seconds it goes up. And then 4 seconds it hits 0 again. So 4 seconds. For how many seconds is the ball more than 48 feet up in the air? This one is depending on what we have. We had 48 at 1 and 3, so I would say 2 seconds for that. And determine all values of t for which h is greater than 48. So that's pretty much the same as this here. We have it's greater than 48 past 1. So when t is greater than 1, but also when t is less than 3. Okay, so between 1 and 3 there. So this first example, again, walked you through. I am going to post the next two in a little bit, but we are going to try 2 and 3 on our own, and then we'll watch the video for the answers. Okay, example number 2. On top of a hill, a rocket is launched from a distance 80 feet above a lake. The rocket will fall into the lake after its engine burns out. The rocket's height, h, in feet above the surface of the lake is given by this equation. H equals negative 16t squared plus 64t plus 80. T is time in seconds. Graph h. So I'm going to clear this out just so I can keep showing you here. Negative 16x squared plus 64x plus 80. And it tells me to use the table. So I have these values here, T and H. 0 is 80, 1 is 128, 2 is 144, 3 is 128, 4 is 80, and 5 is 0. Again, I should have 20 here. I have to go all the way up to 144. So let me just see, 144 divided by 27. I guess I'll go by tens just to make it. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 1, 30, 40, 50. Okay. And we could spread out our stuff here. I could go by halves if I wanted to kind of spread the graph out. Okay. But 0 was 80 this time. Okay, that's because it's 80 feet above. 1 is 128, 20, very close to 130. 2 is 144, about right there. 3 is 128, 4 is 80, 5 is 0. 0, 1, 2, 3, 4, 5. We connect the dots here. Again, the rocket gets shot out, boom, and hits the ground. Remember, no arrows here. What is the maximum height? Okay, look at the table or the graph, 144 feet. How long does it travel upward before its engine burns out? So that's basically where it hits its peak. So it hits its peak at 2 seconds, so it travels 2 seconds upward. After how many seconds will the rocket hit the lake? That's where it goes down to 0, 5 seconds. Nice and easy for that one. Again, we're graphing here, so that's the big thing here. And real world problems, there's no arrows. Again, you can't have negative seconds. In this case, you can't have negative feet. Once the rocket hits the ground, done. And a pistol is accidentally discharged vertically upward from a height of 4 feet above the ground. Its path is given by negative 16t squared plus 64t plus 4, where h is the height of the bullet in feet and t is the time in seconds. Use your calculator. Okay, so first I'm going to go to y equals, I'm going to plug this in, negative 16x squared plus 160x plus 4. I'm going to use my table here to see 0, 4, this is t and h, 1, 148, 2, 260, 3, 340. You don't need to write this down, I'm just writing it down to show you. 388, 5, 404, let's see how long until, okay. I'm just going to kind of skip, at 10 it was 4, at 11 it's negative 172. So we don't have a set 0 here. Oh, I should actually, yeah, 404 was the vertex. That's good to know in this case. So if we were to sketch something, remember we go on quadrant 1, it does start a little bit above the ground and it shoots up and it hits the ground here between 10 and 11 seconds, if we did have to approximate here. This is T, this is H, our scale here. Again, I kind of did a rough sketch here. After how many seconds will the bullet start coming back down? Well, after 5 seconds. What's the maximum height? Well, we checked that, 404 feet. And to the nearest whole number, so rounding here, how many seconds will it take the bullet to hit the ground? Okay, so we do have to look at our table here. At 10 seconds and 11 seconds, which one is closer to 0? So at 10 it's at 4, at 11 it's negative 172. So if I were to be rounding here, 172 is further away from 0 than 4 is. So if I did have to round, I would say 10 seconds. And that kind of makes sense because at 5 seconds it was at its vertex. So if it started relatively close to 0, it takes half the time to go up, half the time to go down. That's not the case for all of them. If you notice in example 2, it started at 80 feet, so it went up 2 seconds, but then took 3 seconds to hit the ground here. Okay, so hopefully this video helped, and again, pause it where you guys need to graph, rewatch it if you need to, go back wherever, and hopefully this helped. Thanks, guys.